Hi, I'm just going to go over our report and explain some of the attacks we did and what our findings were. Did you have any questions when you read the report? Okay, I'll get started then. So for the first part of our test, we did a network penetration test, which basically simulated what an attacker could do if they had access to your network. Doing this, we were able to capture user password hashes and perform Kerberoasting, which allowed us to get credentials from Kerberoast tickets. We'll go into more detail on these when we get to the individual vulnerabilities. For the second part of the attack, we tested your Juice Shop website. On this website, we were able to find that it's vulnerable to SQL injection attacks, which allowed us to bypass authentication to get logged in. It also allowed us to log in as any user we want as long as we have their email address. The website was also vulnerable to DOM-based cross-site scripting, which allowed us to inject JavaScript code into the web page. The website also had broken access controls that allowed us to view other users' shopping carts. So some of the key recommendations here are to disable the legacy protocols such as LLMNR and NetBIOS. Also using some kind of more protection features such as LDAP channel binding could help prevent some of the attacks we did. Also using strong passwords is something that could help too. And then for the website vulnerabilities, just sanitizing the user input so the website doesn't execute the code that the user enters is a big way to help protect it. So one of the key strengths of your network is that you're using Active Directory. This is really good to have some kind of access control method in place. So, and if you disable the legacy protocols like LLMNR and NetBIOS, I think your network will be in a pretty good shape. So here's the list of specific vulnerabilities we found. I'll explain each one of these. So the first one is LLMNR and NetBIOS poisoning. The way this works is the victim one computer, when it comes online, it sends out a request to find a device on the network. So it tries to send a request to the DNS server to see where the device is. And then if the DNS server doesn't know, then the victim one computer sends out using NetBIOS or LLMNR, it sends out a broadcast request trying to find that device. So what we did is we were running a tool called Responder on our attacker machine that allowed us to impersonate other devices. So once we received the request, Responder was able to reply and say, yes, I'm the device you're looking for. And doing this allowed us to capture the victim one machine's password hash. So the key way to prevent this is disable LLMNR NetBIOS using group policy and Active Directory. Also, segmenting your network to reduce the broadcast domains will help protect against this too a little bit, because if it sends out a broadcast request, if you segment the network, it won't broadcast to as many other devices, so then it'll kind of reduce the odds that an attacker would be on that broadcast domain. So using the password hash we captured from doing that attack, we were able to crack the hash using Hashcat so then we could uncover the plain text password. So this vulnerability is mainly just because of weak passwords. If you enforce like stronger passwords, then even if an attacker could get the password hash, they'd have a harder time cracking it. And then also using multi-factor authentication where possible will help protect your network too, because even if an attacker can get the password, if they don't have those other methods to authenticate, then they won't be able to get in still. So the next thing we did was an NTLM relay attack. Basically with this, we were able to intercept traffic going to the domain controller. So we used a tool called NTLM Relay X to forward this request, and then we were able to create ourselves a computer account on the Active Directory domain. So this is bad because basically we can create an account in your Active Directory environment that wasn't authorized by you. So a way to prevent against this is disable NTLM authentication where possible. Using LDAP signing and LDAP-S with channel binding could prevent this. And then just monitoring your Active Directory environment to see where new accounts are created. If one shows up that you don't recognize, then you'll know that maybe someone made an account when they shouldn't have. So the next thing we did using that computer account, we were able to perform Kerberoasting, which is using Kerberos. We could use that account to get Kerberos tickets, which allow us to access other devices and services on your network. So we were able to get that, and then we were able to capture a ticket and then crack it to get the password for an account called IIS-admin. So the way to prevent this is just also using strong passwords. So then it would be harder to crack it. And then moving on to the web application test finding. So this one is SQL injection. So in the login field, the login field's like for email. Instead of typing in a valid email, you can type in code for SQL that can mess up the statement. So when you try to log in, the way your website is set up is it tries to find a record in your database that matches the user's email, or like the email and the password that the person trying to log in entered. So instead of putting in a valid email, we were able to put in this code right here, and that broke the statement. So it allowed us to bypass authentication completely, and also doing this, we could also log in as a specific user. So instead of typing this code into the email, we could type in a user's like a valid email and then type the code that breaks it after the email, and then it would let us log in as that specific user. So this is, of course, not good. The way to prevent this is to make it so user input to those characters that would mess up the SQL statement, basically just sanitize the input so those don't execute. And that's a good way to protect against that. So the next attack is the DOM-based cross-site scripting. In the search bar of the website, we were able to inject this. We were able to type in this code here, and then we caused it to generate an alert here on your website. And then seeing down here, when we inspect the web page, we can see that the code we typed in was added into the website. So this code here is harmless, but it just shows that someone could type code in there and have it run on the website. So the way to prevent this is to also just sanitize the user input. So the last thing we found was broken access controls. On the web page in our request, when you're viewing your basket, you can see that it shows the ID of the basket. You're able to just change this request. Well, here you can see, so we're logged in as Stan on this website, Stan at Juice Shop, which is ID 20. But then in the request to view the basket, we are able to just type in whatever we want for the basket number here. So we were able to view user number 2's basket. So this could allow things like, I don't know, impersonating other users or doing things that you shouldn't be. In this case, maybe like viewing another user's cart might not seem like the end of the world, but someone could perhaps use this to do, I don't know, place an order from another user or something like that. So the way to check this is just implement access control checks that make sure that a user is the user they're supposed to be. And then also for the IDs, they were kind of just sequential. Like you could type in 2, 3, 4, 5, and each one will come up with a basket. So using some more complicated kind of ID system where then an attacker would have a harder time just guessing an ID number would also be good. So that was basically the testing we did. The key recommendations are disable the legacy protocols, enable protection such as LDAP, channel binding, and also for your website just to sanitize user input so they can't run code, and to enforce stricter access control checks. So, do you have any questions? Okay, thank you. Have a good day.